Hello everyone, my name is Geir Engdahl. I used to be Geir at google.com, now I'm Geir at skylib.com. And I'm Geir at skylib.com now because I believe that the way we consume stuff today is broken. And I'll tell you why I think it's broken and what I intend to do to fix it. But first, let me ask you a little question. What do these objects have in common? And I'll give you a little bit of time to think while I introduce these objects. First one is a bicycle rack. And then we have The Art of Computer Programming by Donald Knuth, which I'm sure some of you are familiar with. We have a waffle machine. We have the complete series of Allo Allo DVD set in a big box. We have a keyboard, some ice skates, precision saw, a barcode scanner, string cutter, and something that we call a takke in Norway. It's for making traditional treat, lefse. We have a set of screwdrivers, and last but not least, a sewing machine.
It's all stuff you use occasionally, but many people own one, and it's
That's great. Yep, besides the fact that you can borrow all these things for free on SkyLib in Oslo right now, that's exactly what I was looking for. They are occasionally being used, but usually collecting dust. So what usually happens when we need something like this is we go to the store, buy it, a new object is created, and we use it once, and then it goes on to spend the rest of its miserable life collecting dust on some shelf or in a drawer, or even worse, in the garage. I showed this slide to a different audience a couple of weeks ago, and there was an American there, and he immediately exclaimed that this wasn't even a bad garage, it could have been way worse. And he's right, you can see this continuous strip of floor all the way to the door at the back. So you can tell the state of a garage by the rock climbing difficulty of the simplest route to the door in the back. So there's lots of interesting things you can do with garages, but apparently storing a car in it is falling out of fashion, because a study this year found that 3/4 of American households cannot fit a car in their garage because of all the clutter that's there. This is what I'm going to be talking about today. First, I'm going to tell you a little bit about my personal motivation for creating SkyLib. Then I'll go on to talk about SkyLib. And I'm not going to say too much about it because SkyLib is live. You can go there and try it if you want to. And then I'll move behind the scenes and give you some of my experiences with using Google technologies to build this product. So this is the Grim Reaper slide, the fire and brimstone thing. We are using more resources than the Earth can sustainably produce. So we have this new holiday it's not a public holiday, but it's a day that's celebrated every year. And the strange thing about this day is it moves every year. It's called Global Overshoot Day, and it's the day where we've used up all the the sustainable capacity of Earth. It keeps moving forward. I believe it's in August now. Once it reaches July 1st, we'll be at 2 planets of consumption, versus we only have 1 planet. So it's a little bit of a paradox how we managed to get to this point. But to explain it, you can think about a forest. You can chop down more trees than are regrown every year for quite a number of years until you run out of forest. One other thing that we can take away from this chart is that not only is our footprint increasing, it's actually accelerating. If you look at the carbon intensity of our economy, the last 40 years, it's been the amount of carbon emitted per GDP has been going down by about 0.7% a year. And you would think that with the recent focus on sustainability and climate change, that number would be accelerating, that we would be better at using technology to create goods and services in a more efficient manner. But the last 10 years have seen no change in carbon intensity. It's actually the same as it was 10 years ago, so it's kind of stagnated. And top two reasons for that is one, we've been moving production to China and places where the carbon intensity of production is higher than it used to be in the Western world. And the fossil resources that we are using to fuel our economy are getting dirtier and harder to get. It used to be you'd put a straw in the sand and oil would just flow up. Now you're digging oil out of the ground in the tar sands of Alberta. It's kind of getting harder to get at, and the amount of emission per barrel is increasing. And as you can see here, the carbon footprint is the largest single component of this total. So where is that coming from? Well, the traditional way to look at it is to look at it by fuel source. So we'd have this diagram. There'd be coal, there'd be oil, there'd be some natural gas, deforestation and cement making, and agriculture. But I like to turn it around and look at the other end of the pipeline from the consumer point of view, because I think that's more useful in terms of figuring out what you can do yourself to decrease the footprint. And here you can see that from the consumer point of view, the household carbon footprint, the largest component is from mobility. That's your car, getting around, transportation. But there's also a large component in the lower left here that's manufactured products. And that is the embodied energy and carbon footprint associated with the manufactured products that we buy and use. And that's not including food and clothes. They have their own separate things. So that's about 1/7 of the total. So when people ask me if I'm trying to save the world, I say no, I'm only trying to save 1/7 of it. The other 6/7 someone else will have to deal with. Which isn't entirely correct, because I do care about the mobility part too. A couple of years ago I made this. There's a traveling salesman solver for Google Maps. You see Google is present. And I think it's one of the examples where you get all the incentives right, because you're saving time, you're saving money, and you're saving the environment by visiting, when you're driving around to multiple locations, visiting them in the right order. Back to stuff and the carbon footprint of stuff. This is a chart that Hans Rosling would love. It contains a lot of information. And then you can see on the x-axis the carbon intensity per dollar of each of these product categories. So you see to the far right here, you have the things that give the most pollution per dollar spent. And you have red meat. I actually did the math for Norway, where you would, if you buy, say, $100 worth of gasoline and you light it on fire, you would pollute less than if you bought $100 worth of the red meat. So it's a very, very efficient way of polluting. And the size of each circle here is the total amount for each product group that's emitted. So that's, the amount of money that we spend on each group multiplied by this carbon intensity. And the largest circle here is one of the white circles on the left. It's auto vehicle manufacturing parts. So that's not driving your car around, that's producing the car. Actually, the second largest here is tools and supplies. And there's also a large white circle with appliances and equipment. So those are the circles that are more interesting to me when it comes to SkyLib, because I think there are lots of underutilized items lying around in these categories. So let's dive into an example of this. When we are looking at, actually don't panic here. See, it's a beer, but don't panic because the beer does really well in this sense. It has a very low carbon footprint per dollar. You see 1 liter of beer ends up at about 0.6 kilograms. And how much is beer? You know, where I come from in Norway, it's like $10 per half a liter. So you can safely spend your money on beer, and that's going to be better than most other things you can do. But it's interesting because you see how this life cycle analysis works. One of the things that surprises a lot of people is that the transportation component is not very large, because we hear a lot about these products that travel far, and that's it's obviously worse than having products that travel short, but it's actually a small portion of the total for many different categories of products. So if you look at the biggest part here is manufacturing, and the biggest component of that is power supplies. So that's powering the factory, usually with electricity, but that electricity comes from a mix of power sources where there's a lot of fossil fuel. You have grains, because to make beer you need grains, and the farmer has a diesel-powered tractor, uses fertilizer, etc., etc. And there's a brewing process, and there's a chemical reaction going on to produce that alcohol, which has a CO2 byproduct. There's some trucking, and that's not the trucking to get the finished product to the market. It's moving the ingredients to where they are put together. So it's earlier in the production chain. And then you have all the packaging. You have glass, aluminium, and metal. And you have a variety of smaller things. So they're not very large, but they do add up. Transportation, mostly by truck, a little bit by air and rail, but not very large. And then there's a pretty big thing on the trade side, and that's lighting and electricity for the fridge in the store where the beer is waiting to be bought. And there's also a warehouse part component on that. But in total, the beer does pretty well. So now you can imagine me having learned all this. We're spending way too much resources, we're polluting way too much, and everything that we do has a carbon footprint, and my computer breaks down. So I have the choice of tossing it out and buying a brand new one, or I can try to fix it. Naturally, I try to fix it. It turns out the hard drive is the component that went down. So I order a new one, and what better to replace it with than an SSD disk? So I get my SSD disk in the mail, and I'm halfway through the process of replacing the disk, removing all the little screws in my MacBook Pro, and I meet this tiny devil of a screw with a different pattern, and a little Googling later reveals that it's a T6 torque screw, and I need a T6 torque screwdriver. Notice again the use of Google technologies. So I go on a quest to try to find this screwdriver, and it turns out to be pretty hard to find. The first store I go to, the man who helps me look through all the screwdrivers in the store sums it up when he says, I guess you're just not meant to open that computer of yours. So thank you, Apple. But I didn't give up. Went to the next store and I found a set of screwdrivers where one is the right screwdriver. So I know that screwdrivers too have a carbon footprint associated with them. And I know that I'm only going to use one of the screwdrivers in this kit of screwdrivers once. So I tried to reason with the guy selling the screwdrivers, and it went a little bit like this. So I wasn't very successful. But the idea of SkyLib was born. So I went home and I did a little exercise that you can do as well. You grab your favorite map and you draw a circle around where you live. Radius of this circle is 200 meters, so that's your immediate neighborhood. And then you try to count or estimate the number of households inside that circle. And then you multiply by the number of items that each household has. Now the average household has how many items? Any guesses? Any other? So by the time a child reaches the age of 7, it has on average 500 toys, or has received that number of toys. So you're a little bit on the low side, although these numbers are from the United States, so they may be different. For Europe, it's about 10,000. So within this circle, we have about 1.5 million items. And if you go online and you look at the biggest product catalogs out there, that's 1.7 million items, and they have pretty much anything that you can think of. And I'm sure there's a lot of overlap here, but I also think that you can see that there's a huge resource sitting here, and most of those items are not used daily. So say hello to SkyLib. What SkyLib does is it makes your stuff searchable. So the problem with the inventory on the last side is it's not searchable. If you want to find your T6 Torx screwdriver, you need to walk around the neighborhood and knock on people's doors, and it's socially awkward, at least for us Norwegians. And you know, they may not know that whether they have T6 screwdriver or not, because they didn't index their stuff properly. So SkyLib uses a bit of mobile magic here to accomplish the indexing of your stuff. It's not that your phone is actually going to crawl around and map the stuff, but you can walk around and use the barcode scanner function on your cell phone. Scan barcodes, and the app looks up various databases online, tries to find all the information it can about the product, and puts it in your private inventory. And it's very important that we find as much information as possible, because that makes it more searchable for others. If you're adding a kit of screwdrivers, it's a bit tedious to list all the different types of screwdrivers that are in there. So this should be done preferably for you. If the information that we find automatically is incomplete, then we ask the user to edit it, but then all subsequent users get to benefit from that added information. When you add an item, you choose who can see it. So it could be just your friends, could be friends of friends. That way you reach a lot more people and you still have some degree of trust. It could be everyone. Most of the items that are shared on SkyLib today are shared with everyone. And it's about 1,000 items, mainly in the Oslo area in Norway, that are shared. You can share just with yourself. I know quite a few people who could use a search engine for their stuff. You can share with different groups. You can create a group for the building you live in, or your employer, workplace can have a group, or your sports club, or whatever. And you can also, yeah, those are the modes. Now that we've indexed the stuff, we can search it. And this works pretty much like your favorite search engine. You enter the search query, what you're looking for, and you get a list of results. With SkyLib, it's incredibly important that you find what you're looking for within a short distance of where you are. Because if you have to travel 500 kilometers to pick up that book, that's actually worse than creating a new book. So the carbon footprint of a book, an average book, is about equivalent to driving a gasoline-powered car 130 kilometers. It gives you an idea of the radius. Preferably, your neighbor has this, so you can walk 50 meters and get it. Oh, and if you're searching on the cell phone in the app, it uses your present location. So if you're traveling like me, you're in a different city, and suddenly you find out that you need a camera tripod or something to take good pictures, then it'll actually find the one that's closest to where you are. So, to the behind-the-scenes part. SkyLib runs on Google App Engine. I'm using Java on App Engine, so you have the Java Duke here. You can actually share, it's actually shared on SkyLib for some reason, this Java Duke doll. So if you want to borrow it, you can. The reason I went with Java is it's the language that I'm more familiar with among the 3 languages offered by App Engine. You have Python, you have Go, and you have Java. And the other reason is I could reuse some of the data objects written in Java on the Android application, because that's Java too. Now the reason I went with App Engine is because of its scalability. So in 2011, a terrible earthquake and a massive tsunami hit Japan. One of the things the tsunami did was it knocked out the power plant at Fukushima, and there was a lot of fear about radiation in that area. And the days following the event, the disaster, I was looking for information about radiation values, and I couldn't find them in a format that was useful to me. It turned out there were measurements of radiation, but they were hidden inside PDF files that were generated in Japanese every 15 minutes. And these were measurement stations in elementary schools around Japan. So this German dude, German engineer, his name is Marian Steinbach, he scraped those PDFs and made CSV files of the measurements. And then I took those CSV files, put them into a MySQL database on my personal homepage server, and plotted them on a map. And you could actually click on each of the measurement stations and you can see the historical values. Again, notice the use of the Google Chart API here. Now, when I was done building this, and it only took a few hours, I sent an email to Marian Steinbach thanking him for the data, and he tweeted about it. And then 20 minutes after that, I get an email from my host, Bluehost, telling me they have closed my account due to excessive loads. So it turned out it wasn't just me who were looking for this kind of information. A lot of people were interested. And this is one of the situations where App Engine really excels because it scales with traffic. It automatically spawns new server instances for you when you see more traffic. But a lot of developers are initially disappointed when they go to App Engine, because when you're developing your app and you're developing it on your own box with the MySQL server running on that same box, and there are like 20 records in your database and there's only one person hitting it, and that's you, it feels a lot snappier on your one box than on Google App Engine. That's because even though there are only 20 records in your data store on App Engine, it has all the infrastructure to scale to 20 billion records. It has the load balancing, and the data store isn't running on the same machine as your business logic code. So there are actually remote calls going back and forth. And I think these two images illustrate the difference between speed and scalability here. Because with only one passenger, the Formula One race car is a lot faster than this huge, bulky ship. But with thousands of passengers at the same time, it doesn't move at all. And the bulky ship does, but with one person, it feels slow. That's not to say that I haven't done a lot of performance tuning to try to get App Engine to be faster, because that's one of the things that you will be doing as a developer on App Engine. You will spend a lot of time on this. And one of the things that developers in general are not that used to is struggling with startup time. Because when you're deploying your Java app in normal circumstances, you have your deploy script, it starts running the program, and that startup time can be pretty long if you have those massive frameworks that manage your data and web templates or whatnot. On App Engine, because it scales and because it spawns instances when you need them, server instances, that startup time becomes crucial. Because let's say you have 0 instances running because your app hasn't gotten very popular yet. Then the first guy who comes to your service is going to have to wait for your program to start, for the Java virtual machine to start. And it takes some time. If you look at the chart here, there's only a tiny bit of that time that's the actual processing and the user's request. Most of it is startup time. There is a way to solve this. You can specify that you always want at least one machine running. And you can do that with the free quota that's provided on App Engine. You have to enable billing to do this, but you don't actually have to pay, because you'll be right under the free quota with one machine running all the time. But whenever you need extra instances, whenever a new server instance starts, a user dies. It dies in the sense that he has to wait for this new machine to spin off. It's something that I haven't been able to figure out how to solve yet. What I'm doing right now is I have 2 machines running at all times, so this doesn't happen very often. But for this, automatic scaling to work well, it would be nice to never send new users to new machines until they've actually done all the startup.
So you're saying there's no way to delay getting traffic until you want.
Yes, there's an open issue on App Engine right now. The other problem that I've been struggling a lot with when it comes to App Engine is sometimes App Engine is slower than it usually is. So it doesn't have much downtime, but it does have some slow time. And if your startup time is 20 seconds, during those slow time periods, it can increase to 40, 50, and maybe 60 seconds. And there's a hard limit on each request at 60 seconds. So if instance startup time is more than 60 seconds, they don't start at all. And that translates that downtime or a slow time into actual downtime for your application. So there are a number of things that you can do to speed up startup time on App Engine. Getting rid of the heavy frameworks is a hard sell when you've written all the code, but if you're just starting out, it's something that you should consider when picking framework. If it looks like the figure here with lots of different boxes and lots of features, it could be slow when it comes to startup. I'm using a security framework called Apache Shiro. And it's a very lightweight framework, actually. But it does use reflection as a Java language thing for initialization. And that was super, super slow on App Engine. It added alone 10 seconds of startup time on good days. So replacing that configuration by ini files with configuration that's explicit in your code makes that, takes it down to less than a second. So avoid reflection. So here's my Christmas wish list. Number 1, user-facing requests should not be sent to cold instances. And number 2, improve Java instance startup time. And I actually have a suggestion for how to do this, because you don't actually have to improve the startup time. You just need to increase the request limit, if that's possible, for startup requests. Not the regular requests, but if startup requests could take more time, then Java developers can use their heavy frameworks that they're used to. And as long as the first issue is solved, no users will be killed in the process. And Google recently introduced this awesome full-text search API that holds a lot of promise. It can do a lot of cool things for App Engine, and I'm using it. But as long as there's a hard request limit on number of requests to it per day at 20,000, it's not very useful, because every time you index something and put it into that full-text search API, you use one request. And there's no batch way of doing that. So, SkyLib contains about 10,000, more than 10,000 items now. If I need to re-index that for any reason, say I want to add a field or something, then I first have to remove each document, which takes one operation, and then add the new version of that document, and then I've blown my request quota for that day. So those 3 things would make a very Merry Christmas indeed. And if there's no Google Santa in the room, it would be great if this could be forwarded to the Google Santa. Yeah, and then some sources that I want to show, so if people are interested, they can actually look at the data for the slides. That's about it. Next time you need something, one of the usual suspects of dust collection, remember that SkyLib exists. And if you can't find what you're looking for, make sure that you put it in the cache SkyLib after you've used it. Thank you. Now, questions? Yes?
One question. You said you were actually, what's the reason you didn't try it?
It's simple. I was at Google before, And the reason I left Google is actually I felt homesick. I wanted to go back to Norway, so I didn't have this idea then. But I think, yeah, that's a great point, because with Google's resources, you know, obviously it's easier to get that critical mass of users that is necessary to make this whole thing useful. Yeah.
Do you consider using Amazon security or providers?
Yes, I did consider the other providers, but given my background, I always felt that, you know, Google is the best. And actually, there's a difference between App Engine and Amazon as platforms. Whereas Amazon, you do much more of the configuration on your own, and it doesn't auto scale. You actually have to request the extra instances yourself, and you have to deploy to them, and you have to do a lot of things that you get for free with App Engine. I'm not the SRE type of guy, so I want to do coding, but I don't want to do maintenance and deployment scripts and all that. And with App Engine, you have that. You have the deployment in a web interface. It's really simple. You can do, you know, traffic experiments. You can direct half traffic to the new version. You get lots and lots of stuff for free.
SkyLib is available on Android and on the phone, and on the computer, on the desktop. What about the payment plans for SkyLib?
Yes, so SkyLib is available on the web at skylib.com and in the Google Play Store. I'm building an iPhone app because people are nagging me. It's not that I particularly like Apple. But yeah, so the iPhone app is the next step.
And what was the plan to get sort of critical mass of users? I guess there's you can have some amount of users, some amount of items, I guess.
Yeah.
Given the issue before it's necessary.
Yes, so the plan to get the critical amount of users is to focus on a very small geographical area. So I kind of pick the battleground, which is going to be likely around university campus in Oslo, and the student housing areas where people live close, they live on limited budget, and yeah, they have the technology and they're pretty tech savvy.
Actually, wherever you can come to see, set a screen up it's very local. So basically, when I go home now, I can try reminding.
Yeah, but you need that. You need some amount of it.
Yeah, and the thing is, I do not involve the kind of critical mass in the line. That's totally allowed to do. As long as it as I can get my input, it's okay. So, good job.
Yeah.
Bit of background, so before I joined Google 20 years ago, I had basically the exact same idea. One thing that I thought was crucial, and I mentioned that the American is that I tend to forget. I tend to forget that people have a lot of stuff to do, and I tend to forget that I should be giving people back. And if you have an Android app, it should help you in terms of learning. For instance, whenever I go near, or when it seems I have an appointment with someone whom I farm, this would remind me that I should bring them back. Or if I go through them and I signal interest in certain things, and you tell me, by the way, they have one of these things like one else yet.
Yeah.
Stuff like that. I think it can really help.
Yes, that's one of the main features. A lot of people borrow from others, or they lend to others, and then they forget about it. So it's kind of like giving away the things. Well, SkyLib does have a record of your transactions within the system, so you can see who's borrowed.
I think the record is not kind of good, but it should go further and then actively help me like kind of fulfill my social contract.
Right. Yeah. Yeah. So this isn't. Yes, this hasn't been done yet. I'm working out how the borrowing should really work in practice to be the best it can. One of the things is a limit on how long you can borrow something. And when you have that, you have the opportunity to give reminders and try to make the exchange part easier. I have focused on the search part for now, mainly because I'm just one person developing it, and there hasn't been that many transactions yet. So I think there have been about 20 non-me transactions so far. But yeah, I think that's one of the next things that I will be working on, the transactions themselves, and making it safe and very convenient, and helping you remember what you should do. Yeah. 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 Yeah, actually, that's a super idea. I think. Yeah. Yeah, I think that the messaging is good, and hopefully, I haven't looked into this, but maybe it's easy to integrate with Google Talk and have some sort of widget. Yeah, that's a great suggestion.
Beyond that, integration with Google Plus or Facebook, should I say I added this item to the Skyb?
I'm planning for that. The only integration right now is with login. You can log in via your Google account and your Facebook account, and it pre-fills some of the information about you, like your name and picture. But that's coming. That's just limited development bandwidth from my side. Right?
But it's interesting. You mentioned increasing cost of in the beginning it might be a small subset. So with time, it can get a lot of things. But even you put online yourself, you forget what you have put it out there.
Yeah.
You have a self-interface for each individual user, like, so I can know, and with time it will be interesting for me to see my household.
Yeah.
What are the things, especially if you have a
Not just what do you have, but how you put it in that.
yeah, something like that. Because you have a picture that you can kind of remind the location.
Yeah.
When I tried to tell her my wife, that is exactly the one point that made the sense.
Yeah, because not just for other users, self-users as well.
Yeah, there is a simple inventory thing right now, but it can be made a lot better, I think. Right now, it's just a list of your things. Yeah. Yeah. And it would be super cool if, in a few years you'll have some sort of indoor navigation thing, so the phone will know where you were when you indexed the thing. I know libraries do this, but they have some sort of barcode on the side of the book. So I don't know if it would work yet, but maybe it can be done. Yeah, because you have the Google Goggles thing, right, where it does recognize. Yeah. Or put it in your Google Glass, and then you can just walk around and look at the. Yeah. Yeah. Right. Well, thank you for showing up, and thank you for making great technology, and keep moving the world forward.